badly.
Is there sound now?
Yeah, I just double checked. Thanks, Joe, for making sure.
Why is it so hard for me to remember cosecant and secant? Is cosecant a thing?
Cosecant. Derivative of sine is cosine. Right?
Oh yeah, I was just saying in general.
Oh, cosecant is a trig function. So Patilla, Joe Shaka. Alright, you guys ready for me to start playing?
No.
Oh, I need to start playing, Joe. You ready for me to start playing?
Oh, yeah.
Okay. Hopefully most of you guys have already realized it's 0 over 0 if you know the unit circle. Because if you plug it in like we start any limit problem, 0 minus sine of 0, what is sine of 0?
1.
Uh-oh. Well, we already know that we're not good at the unit
cosine
circle.
0.
What is the very first forever card you need to study?
Sorry, it's 0.
Okay. Remember, if worst comes to worst, shouldn't you know what sine looks like? Could on the forever final on Friday, could there be a sketch this? Or what function has this graph?
Sine.
Who's this? Sine? I mean, it's a little bit lopsided, but fine. Where is sine at 0? 0. Look, 0, 0. At 0, sine is 0. Where's cosine at 0?
1.
He's up. He's 1. Just in case, if unit circle isn't a thing that... I don't even know how to finish that statement. Anyway, memorize it. But 0 minus 0 is 0. And 0 cubed is 0. Do I have an indeterminate problem? So therefore, what do? L'Hopital's, for those of you guys just joining us, they were working on an additional problem from yesterday. L'Hopital's, and I gave them a hint that L'Hopital's is possible. It's possible because possible. If it wasn't indeterminate, it wouldn't be possible anymore. So derivative at the top, did you guys figure out 1 minus cosine over 3x squared? Yes. Am I doing quotient rule? Absolutely not.
No.
I am doing L'Hopital's, which says just take the derivative, take that. Now, is quotient rule still the only legal way to take the derivative of a quotient? Yes. I'm not deriving this. I'm using L'Hopital's rule to say shortcut. We like shortcuts. So when I go to plug in, what's cosine of 0? Just 1. What's 1 minus 1?
0. It's still 0 over 0.
Do it again. Oh, okay. Okay. I can do derivatives all day long. Why would I keep taking derivatives? What's happening in the denominator?
The x, you're getting rid of the x.
I'm slowly getting there. But as I get rid of the denominator, I also have to be deriving the numerator and making sure I still have indeterminate form. Derivative of cosine is negative sine, and negative times a negative is a... Plug it in. Serious? Oh, stop. We're almost there.
Yes.
It's
okay.
X over.
Oh.
Derivative of sine is? Positive cosine. Derivative of sine is cosine. Wait, she put an
Not zero
equals.
anymore.
Why did I put an equals?
1 over 6.
Cosine of 0 is 1.
1 over 6.
Dun, dun, dun.
That's it.
This was impossible to do without L'Hopital's or without some crazy trig formulas from last year, composite arguments, and the limit definition. I see you, Joe. Give me a second. Limit definition of the derivative. Joe, what's up?
Is L'Hopital from France?
He's probably a French guy with a French name. I don't totally remember, but he was from a long time ago. You can always research him.
Does he have a doctorate degree?
I don't know, Joe. It was a while ago. Matthew.
Could you ever get a L'Hopital's problem where it would equal 0?
Where it would equal 0.
Yeah,
Yeah,
where you find-
because if, for instance, let's say that this was switched, right? If it was switched, well, actually, no, that'd be 6 over 1, which is 6. There are times when you go to plug in and in the top everything has disappeared and so you're left with a
Nothing.
0. But maybe the bottom has a constant. So 0 over anything would be 0. So yeah,
So
you
it's
could get
legal
0 out of it.
On the final, this is gonna be. Is it gonna say like solve with limit, or like are we gonna get
On
to
any
choose?
multiple choice problem, if there's a limit, you have a choice of how to solve if it's a 0 over 0. I won't force you to do multiplying by the conjugate versus L'Hopital's, or factoring versus L'Hopital's. Does that make sense? So if it's a 0 over 0, or technically if it's a horizontal asymptote, which you might realize is an infinity over infinity type problem, you can use L'Hopital's. I mean, you could also choose just to do it the old-fashioned way, but technically after this homework you might realize you like it.
But like, is there gonna be any wrong answers where you're gonna make guesses?
Would I force you to do the old-fashioned limits? No. Not gonna be, no. Not now that you know L'Hopital's. But if it's a limit that's not 0 over 0 or not infinity over infinity, you have to have that limit review ready too. Tony.
No, we used to write keep going again 0 to 0. So we write it like that.
Technically. Because you are keeping going, but you have a new way to keep going. Which is only legal when you have. But good, Tony. So what would be different, do you guys realize we're just doing a couple more additional L'Hopital's examples? What would be different if we were in BC right now, or if we had another like 3 days, we'd do this one too. It starts to get a little intense after a certain point. But we could do this one. Nope, not 0, it's actually E.
Oh, yeah, that's right.
But how do we do that one? Yeah, there was like a memorizing.
The special
something. There's a special trig limits that this was in the future and we were gonna get to, but we'll get to it after.
Oh, I did review that.
But yeah, in E.
That's gonna
But
be
hold
a
on.
choice.
How do I do this?
Common
Denominator. Why wouldn't you just plug in? You would get 1 over 0 minus 1 over oh. Hey, forever card, forever final. Forever card, forever final. Number over 0. Number over 0.
Vertical asymptote.
The vertical asymptote. She's been studying forever.
Only first week.
That's okay. 0 over 0 is a whole. Number over 0 is a vertical asymptote. 0 over 0 limit is keep going. Number over 0 is either plus or minus infinity. Check the sign. If I have a vertical asymptote, could the limit be infinity?
Mm-hmm.
Yeah.
Could it be negative infinity?
Yes.
Or could it be DNE?
Yeah.
Maybe.
So for both of these, wait a minute. What's bad if I have plus or minus infinity, check the signs? Minus plus or minus infinity, check the
It's
signs.
gonna be.
You don't know which one.
Infinity minus infinity is indeterminate. But I want an F over a G for L'Hopital's, right? Endeavor number, forever number 28. I want an F over a G. One F over 1G. What's the problem?
You have 2.
You don't have.
I have 2 fractions. So how do I put fractions together? The old-fashioned, just, I don't know, using my math skills way.
Yeah.
So even if you don't have 1F over 1G, can't you get 1F?
Why did we multiply that one by X?
Because we have to multiply them by each other in order to get the common denominator.
Multiply by
You
y.
cannot just multiply signs.
Because if they're different, and they are different, why? It's not sin times x, it's sin x.
Sin.
He's stuck.
Wow.
He's stuck. Now, if I go plugging in now, oh wait, 0 minus 0 over 0. I see him. There he is. See? that 0 over 0 is an indicator you're ready to do L'Hopital's also. Maybe you weren't ready to begin with, but with one quick common denominator, now you are. Now wait a minute, hold on. This looks an awful lot like the one we just did, right?
Except there's more X.
Except something's different down here. So we can still do our 1 minus cosine x, taking derivative at the top. Oh, but how am I
First D
supposed to do
second, second D
the...
first.
UDV plus
Do we have to
UDV
review product
plus
rule?
UDV.
Hey, that's a forever card. How do I do
Second
that?
D
UDV
first.
Second?
Second.
D first, what's derivative of x? 1. Plus first, D, derivative of sine is?
Cosine.
See how many forevers you have to know just to do like basic calculus problems now? Now, are there still things to study?
Yes.
Yes. But, product rule, let's plug in. What's 1 minus 1?
0.
Let's do 0 over.
What's 0 times
That's
anything plus 0 times...
0.
Keep going.
Do we?
Okay. But that's okay, we did that a second ago, and we got a positive sign when you derive 1 as 0.
Mm-hmm.
And you derive negative cosine as a negative sign, positive sign. Oh, derivative sign, I know that, that's cosine. Oh, we'll have to review again.
Oh,
It's okay to kind of be like sad, discouraged, frustrated, mad. Just keep going though. Second,
I'm just doing one.
Cosine times 1.
D first, plus first.
Negative sign.
Remember it's a times, careful, your brain might think minus. Times, parentheses helps. Sine, 0.
Still 0.
Cosine, is 1. Plus, cosine of 0 is 1 plus 0. Matthew, you just asked me, could you ever get a 0?
Oh.
Yes.
0 over 2. Tyler, is this legal?
0.
Yeah.
Yes. That's it.
No hole.
Do we
Got
have
it.
to write that little LH
That's just my way of keeping going.
That's my French.
It's up to you. It's my way of keeping going.
Okay.
And if you're not forgetting L'Hopital's when it's second semester at the very end, right before the AP, and you have a limit problem, you're like, wow, L'Hopital. L'Hopital. This one is something that you've memorized, and someday maybe we'll figure out why it's E, but for right now, it's E. Okay, let's go ahead and actually there's a really cool session I went to at my math conference a few weeks ago, and it was all about this problem, but the crazy thing is they didn't show any equations, and they still had just like everyday people that didn't know calculus working on this problem, which was kind of cool, kind of crazy. Maybe we'll start the semester off with that, because I was like, whoa, mind blown. You can have kids working on a problem without them even knowing it's a problem, or a limit, or having any idea who E is,
Oh, that's.
or calculus. It was kind of crazy. But anyway, that's not our objective. Our objective right now is to see if I could go to homework, right? And I could open up homework solutions for 3-7 and 7-7, which I'm going to do. I could show you what the evens are, so that if you haven't finished it, you could check the evens via the YouTube video online tonight, right? And I could do that, and that wouldn't be totally useless, that wouldn't be totally counterproductive, but some of you, frankly, haven't gotten far enough to really warrant checking answers. Like how number 6 has a tangent line of that we use and say, hey, he was pretty good as far as approximations. Or how to use a tangent line in number 10 to get something like, well, the delta y is exactly negative 0.3224, but the differential is negative 0.32. A lot easier to do than bleh. I know how to take a derivative, times dx. Or, okay, a few other evens that you guys can use the video tonight to check. Section 7.7, though, is a bit more straightforward on what you're doing. Just realize you can do a couple versions of L'Hopital's if you want to. However, there might be something weird where it was never a L'Hopital's to begin with that maybe someone should ask me about. And then this one's kind of funny. It actually has you go to your calculator, but there was a very straightforward L'Hopital way of getting a common denominator and then taking a derivative. Anyway, those are the end of the evens for 3-7 and 7-7. What I'm more curious about, like I did in period 1, are there any ones that you guys have gotten stuck on that you want to go over? Squeeze theorem 1? Okay, Tyler has a squeeze theorem 1. That's section 7.7. What else? PK.
I have from the first homework,
Yeah.
number 23, 36. Okay, from homework 23. Sorry.
Oh, from homework 23.
Yeah, 36 and 41.
Okay, so that'd be 37. 36 and 41. Joe.
Just number 10 because I scanned the code and then like just show off the same video every like question I scan.
Oh, the scan takes you to the web page. I think you have to find the specific problem.
I tried.
Okay, I'd have to see your phone to look at it. So you're curious about how to use the QR code, right?
The problem itself too.
Oh, problem. So it was number 10 on which one? 7-7 or 3-7?
3-7.
3-7. Okay, so number 10. But yeah, we can look at your phone later and see what's going on. Olivia. 7-7-51. What else? Matthew.
3-7, number 25.
You think 25? I'll
It's the AP.
confirm it for me. For those of you guys that are just chilling and sitting, I have plenty of books up here like Tony just did. Come on up and grab one. I mean, we're basically having a work period for the rest of class. So if you're like, I need to do 3-7, come on up and be working on 3-7. 7-7, be working on it. I want to work on the bonus review. Work on that. Because tomorrow we're taking our quest, which we'll talk about. It's a shortened test. But some of you might want to be work perioding on things other than the question at hand that I'm answering. But I just need you guys to stay focused. If you want to put in music, totally fine. What number was it, Matthew?
25.
It was 25. Good. I'll erase that question mark.
Also, how late are you staying today?
I need to be in the office between like 4 and 4:30-ish, but my room will still be open probably until about 5.
You're the problem.
I'm just saying me personally won't be in here answering questions between 4 and 4:30, but I'll be back 4:30 to 5-ish and then close up the room.
I think Gavin wants to show you
You're
a
the
demonstration.
Right now?
Is it going to be helpful to us for the question?
No, it's not.
Okay, then we need to wait.
But it is really fun.
It
It's
is.
amazing.
Okay. Remind me because I really want to see it. What's up, bud? Go quickly.
This is the way.
All right. Guys, listen carefully. I'm going to go through answering questions. But if you're like, I don't need to pay attention, put in music and work. That's fine. It'll be on the YouTube video. You can totally check it out later. If you're like, I need to kind of listen and maybe follow along with a couple, but otherwise, okay, do what you need to do. If you need to get out your phone, get into Google Classroom, find the assignments, that's totally fine. The review is technically optional. True? And it's a review. You don't have to write directions or problem details or any of those sorts of things. It is a review, but it would be helpful. It's not a practice test, so there is no like bonus practice test, but the review itself is bonus. And tomorrow's test is not a full-length test. It is shorter, it is sweeter, it is kind of like one problem from here and here and here. Where partial credit will be available, even if it is multiple choice. Partial credit will be available, even if it is multiple choice, by showing me work. If you have done your homework, and if you are here tomorrow, ready to go, have a calculator, remember those optimization problems. But I might give you one that's easier, that doesn't need a calculator. That would probably be beneficial in saving you time. The quest for tomorrow should be beneficial to your grade, regardless of how you normally do on tests. Sound good?
Yeah.
Okay, so come, be ready. Oh, but wait, did I get to grade your notes and homework spirals when I was gone? You took a test without me?
No.
Okay, so we're turning in homework spirals having everything up to date, right? And we're turning in notes having everything up to date? I'm going to have to do a lot of grading in a very short amount of time as you guys are questing tomorrow. To be able to do that, if you could please have everything ready to go, the more hundreds I give, the faster it goes. The more points I take off, the slower it goes. So if you can have your notes with every section title written down, every section page number written down. Man, I could just look at it and be like, double check, it's there, 100, it's there, 200s for 2 chapters, ready? And then for homework spirals, same thing. Please grade your homeworks. You're supposed to be grading with me, and if you're absent or if it's not ready, you're grading with the video after in a colored pen, right? Little things to make sure you have hundreds. Okay, here we go. If you don't need me, get the music in and just be listening for when you do need me. Here we go. Number 10 on section 3.7. I am not in 3.7. I'm in the review. Number 10. Number 10 was super similar to the one that we did in our notes. And the one that we did in our notes said find dy and find delta y. So I'm going to do it pretty quickly because the notes was extremely, extremely similar. And you had number 7 that you could check out the video to if you got stuck. So, how do I find delta y? Using the formula in our notes. And the formula in our notes says delta y is equal to f of x plus delta x.
Okay.
Is this homework number 24?
It's the first one. So 23, I think. PK, is it 23? The first one?
Yeah.
So f of would be 2 minus, let's see, my x is 2 and my delta x is 0.01. So I have 2 minus who to the 4th power? 2.01 to the 4th power. Minus, and then f of x is 2. So 2 minus 2 to the 4th power. That's how or what I would need to plug in to solve for delta y, taking my x and plugging in who x is, my delta x plugging in. This is the formula straight out of the notes. What's wrong? You okay?
Yeah.
Okay. To find dy, all I need to do is take the derivative, which is negative 4x cubed. But remember, there is a dx. What do I do with that if I just want dy? I move them. And all I have to do is plug and chug. So I have negative 4 times 2 cubed. What's easier, doing all of that mess or just doing this? Which is why dy is a nice approximate for delta y sometimes. So this one we would have 8, and 8 times 0.01 is 0.08 times negative 4. I would have negative 0.32. Did that sound almost right?
Yeah.
And then over here, ew, gross. I don't even know, but it's going to be close to that. You're welcome. Plug and chug. If anybody needs a picture of it, now's the time because he's about to disappear, and once he's gone, he's gone. Well, unless you want to check out the YouTube video tonight. Matthew.
So we have to do both the delta y and
Only for this one because the directions say explicitly compare delta y and dy. Yeah, only for this one. It's up there for one more second. We're going to number 25 next. Okay, number 25, out to anyone's phone taking a picture. Oops, let's not take a picture of nothing. 25's up here? Nope, he's down here. 25 is a picture, and that picture that it gives you is asking you to use differentials. Wait, isn't that like the tangent line? And to use the graph of f, to use differentials and the graph of x to approximate f of 1.9 and f of 2.04. F of 1.9 and f of 2.04. So, let me see if I can get here. It's a little hard on this one because they didn't give me something to take a derivative of, but they did show me a tangent line whose slope I can approximate because it sure stinking looks like this goes through the point 1, 0 and 2, 1.
X minus 1.
I'm pretty sure it has a slope of 1 over 1. So it looks like my derivative, or my slope, at 2, 1, which is what I'm going to use to get to 2.04 to get to 1.9. 2 is my closest exact point to either of those. I can use my rise over my run, or my differential of 1 to help me out. Now, how do I use it to help me out? I need to get to 1.9. Well, hold on. Didn't we just see that you could solve for a derivative? And you could make your dx the same thing as delta x, which is negative 0.1 on this one. Or how much change I have in this one is adding 0.04. And I can actually say, you know what? I'm pretty sure this is going to change in this first one by approximately 1 times 0.04, which means I'm actually going to have about what it was, 1 plus 0.04. And this one, I'm going to do my dy, it is 1 times negative 0.1. So therefore, for my next one, I guess it was the first one in order of the question. I'm going to have my 1, and I'm going to have it go down 0.1, which will be 0.9. Now, you could have also done tangent lines. It might have been a little bit easier. You would use that tangent line equation, which says plug in a new x when you have an old x. So you could have plugged in, for instance, 1.9 here, which would have been a 1.9 here. My derivative, I would have used the graph to plug in a 1, and I can tell from my graph that this is 1. So I could do 1 plus 1 times negative 0.1, which is what I did, or 1 plus 1 times 0.4, which is what I did. You could use tangent lines. It might have been easier to organize the information, but they technically were saying differentials, so that's what I did. Differential says how different? Approximately 0.04 different, or approximately negative 0.1 different to get to each of those. So a little bit weird in the wording, a little bit weird in what they gave you, but still technically using that slope, that derivative, to help me out. If you need a picture of it, it's going away soon. Matthew.
Did you get 0.4 again?
Oh, I had to think of how far away 2.04 was from 2. Does that make sense?
Yeah.
Yeah, how far away. That's that little delta x changing x. Is it okay?
Oh, yeah.
All right, now we're going to peek at number 36. 36? Ooh. 35? Okay. 35. Not 36.
Oh, sorry. No, you're right.
Oh, 36. The weird graphy one?
Yeah.
Okay. No, you're good. This guy is so easy it's hard. You ready? I'm not going to take a picture of it. I'm just going to go ahead and look at it. Do you see how I have profit, y, I have x number of units, and then it says which is greater? Here's my question. Who? Well, the change in profit when I go from 400 to 401, so from here to here? I can't even see it on the graph. Or the change in profit when I go from 900 to 901. I can't even see the difference between 900 and 901. Like, wait, change. How much it changes. Didn't we just talk about how dy and delta y, change in y, and the derivative are kind of related? How do I think about a derivative if I'm looking at, like, how do I think of p prime if I'm looking at p? Slope. Can you tell which slope is bigger? Because of how steep, or that it's more steep. I have an m1 there and an m2 there, which is the same thing as a derivative here and a derivative there. I don't know the number, but I can tell it's higher. And if it's higher, it's rising faster. Remember, rate of change is rising faster. If it's rising faster, then the change is going to be greater at 900 and 901. So because of that slope of the tangent line being steeper, at 900, the profit is rising quicker, so the change will be higher. Does that kind of make sense? Rate, faster, faster, higher. Yeah. So the slope or the rate at 900 is faster or higher than at 400, which means that change in profit will be higher as well. Number 61 or 41? Sorry, I can't read my own writing. 41. Thanks, Olivia. Number 41 is that last one in this one, in section 3.7. And it was, oh yeah, period 1 didn't like it either. Although, it was so similar to my square root of 123 in my head problem. You guys remember I did that?
I did remember that, but I couldn't figure out how to
do it. Okay, so here we go. You have an idea of what we're doing, but how do we get there? It says use differentials, and I'm not saying it's wrong, but more specifically use a tangent line. So, the formula that I added, or I'm adding into your forever cards, underneath problem solving clues, the equation of a tangent line, how to find the equation of a tangent line, is how to use a tangent line. How do we use a tangent line? we get that y minus y1 equals m times x minus x1, and we say you belong over there, Adam. And we rename this guy just to make it snazzy because we're using him, so he gets a special name. L of something equals y1, which is f of c. I'm adding it, so plus m, which is f prime of c, times my something minus c. So if I was doing this generally, I would have c, c, c's, and then a's just get plugged in here and here. And they're the guy I'm trying to approximate. You might be like, I think 624 is near a special dude, and he is. He's near 625. And 625 is pretty special because I know the fourth root of 625. The fourth root of 625 is 5. And why does that help? Because it's so close. So I'm going to say, okay, so what if I wanted to use the fourth root, or f of c, the fourth root, or f of 625, minus, well, who goes in this spot in my tangent line? The derivative. What's the derivative of 625 is the dude getting plugged in, and it's going to change to 624 in just a second. Isn't my function just the fourth root of something? And the fourth root of something, isn't that same thing as x to the 1/4?
Yeah.
Oh, so I know the derivative of that. It's going to be 1 over 4. Hold on. I think I don't like what it's going to look like. 1/4 x to the negative 3/4. Well, negative, that's down here. Fourth, that's a fourth root. And then 3, that means it needs to be cubed. And who are we doing the fourth root of something cubed? 625. I'm making a tangent line with my function being this guy and my point of tangency being this guy. Here's my point that's close to that, and here's my function. So I plug in x to get my f of c. I plug in x to my derivative to get f prime of c, and then I plug in x. All I have to do to get here is say, I'm using you. I know I kind of have to go off of the curve, but I'm going to ask what's going on here. So wait a minute. We just said the fourth root of 625 is 5 minus. Well, wait. If this is 5, then this is 5. So 5 cubed is 125. And 125 times 4 is 500. Which isn't gorgeous, but I can do it. And then I'm going to plug in 624 right here. So then I can say, well, the fourth root of 624 is 5. Take away, that's just going to be negative 1. So plus 1 over 500. And I could be even super snazzier and say, hey, what's 500 into 1? So I'm pretty sure, even though it's hard, it's not too bad if I just go a little bit further down the line. So I get 5.002 as my approximate of that dude using that dude. A little weird, little out there. The derivative was a little bit harder than the square root of x because it was a fourth root of x, but still very possible if you follow the system. Still very possible if you follow the system. I'm going to switch over to L'Hopital's. So Olivia had a question on L'Hopital's towards the end. But if you guys want a quick picture, it's going away soon. Go on, quick picture, it's going away soon. Okay, let's go ahead and flip over to section 7.7. Whew! Did you guys realize I had to go like way back here somewhere? There's a lot of...
Are we going to get the whole book?
This is technically an AB and BC book, or a Calc 1 and Calc 2 book. We're just doing Calc 1, so it's like half of it.
Oh, okay.
It's like chapter 6-ish. Maybe a little bit of chapter 7-ish, but not much. What number was it? 51. Ooh, he's a pink one. And he's the one that we skipped in our notes. Alright, I guess I have to do him then, huh? We know his answer is E, but why is it E? It is a video.
Just write E.
It is a video. It's harder than anything that's going to be on the quest tomorrow. Oh, tomorrow's 0 period though. That's nice. And if you didn't pick up, if we run out of time, if you don't pick up your test today, you could always pick it up in 0 period and work on corrections tomorrow. Or you could just stay focused on this part. Stay focused on the quest first and then worrying about the rest.
What are those due?
Oh, so many files back here. It's ridiculous. When or what due?
Corrections.
Friday. We're having work days on Thursday or whatever we don't. Whatever extra time we have.
I was so happy about the fire days until this week. So everyone's like,
Oh, you didn't feel it last week? I felt it as soon as we had it. I was like, oh no. Anyway. Okay. So you can totally tune out because you don't need to know it and you're going to memorize that it's E.
Yeah.
The rest of you that are curious, you actually have to start with a y equals. Because if we plug and chug, what we get right now is 1 to the infinity, which is, we don't know. But the only way to rewrite a power to a power you might remember from before is using an ln. But we can't do ln unless we have two sides. Now, you might notice there's no limit. Okay. Well, technically, if this is my y, I'm trying to find the limit as x goes to 0 of y, because stuff's about to change and look funny. I just need to remember what my objective is. Okay, so if I go ahead and rewrite by bringing this 1 over x down, I could rewrite this to be 1 over x times ln of 1 plus x, which is good, but over here I have this weird ln of, well, technically, it's a little funny right about here because I had a limit technically right in here somewhere. And there are a lot of properties that are going to move things around a bit. There are a lot of properties that are going to move things around a bit. For instance, I'm technically allowed to hold the limit on the outside over here. Oh, it didn't work that time. That's a first. I'm technically allowed to pull a limit out here, which is a little bit funny. But I'm going to go ahead and simplify this a bit because now I can rewrite this as, and I have a limit kind of hidden over here as well. I can have ln of 1 plus x all over x, which all of a sudden is a lot nicer because now, because this was over a 1, I just multiplied it. Now I have an f over a g. So if I go plugging in 0, ln of 1 is infinity. Ln of 1 is 0, and 0 over 0 technically. Now I have L'Hopital's. So then I can go ahead and say, sweet, I can take the limit of the derivative, which would be 1 over 1 plus x times 1, all over. Oh. Well, wait, that was way too quick, because now derivative ln of u is 1 over u times u prime. This looks like something I can plug into, because 1 over 1 plus 0 is just, oh, the answer is 1. No, it's not. I told you in a way earlier forever card the answer was E. Why? What's waiting over here? I have an ln of a limit. I know it's weird. There were some limit properties that once upon a time you guys kind of ignored because you were like, doesn't seem like we're using them. I can bring this limit in, and I can actually solve for what I need, which isn't the ln part, it's the other part, by taking an e. And what's e to the power of 1? Dun, 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 dun. I had to use ln to bring the power down to make it into a legal L'Hopital problem. But then, since the ln was still over here, I had to get rid of it once I did finally finish. Dun, 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 dun. Okay. For the quest tomorrow, remember I said it's a shortened test. It's not a full-blown one. For the test tomorrow, there are going to be some multiple choice problems. And let me see if there are going to be any long answer problems. Oh, look, it's our optimization activity. There might be something to do with a fence. There might be something to do with different numbers that we're trying to do things with and find the lowest or highest or this or that or the other. There might be something with didn't we just do a weird fourth root of 624? And I said it was similar to the square root of 123. There might be something similar to the square root of 123.
Like of that.
Of that type of square root, not fourth root, approximating
Okay.
tangent line thing. They're going to be a few different L'Hopital's. But one of them is going to be a bonus because we didn't get into all the hard ones. Well, this was actually pretty beneficial for the bonus.
So can I put it on?
And then you have 114 identifiers. Whose derivatives are given for. And I list out all of the 14 things like I did in class. You just have to fill them in. The x-intercepts, the y-intercepts, the vertical asymptotes, the holes. But I list them out. You don't have to have them memorized, and I don't make you find their derivatives.
Is that like that worksheet that we did, like the little cutouts and they're like,
Oh,
or is that a different?
That's optimization.
Oh.
This is the one that would be great for the fence problem I just hinted at, or you have a couple numbers and you're trying to put them together in order to find the highest and lowest to sum or to product.
And that's optional.
And then what is linearization again?
That's like the square root of 123,
Okay.
one where we make a tangent line and we use 121 until the very end, and then we plug in 123 and see
Okay.
how far.
So we know 14 identifiers from that, and then
Optimization
is fence.
And then
Linear is
linearization,
123.
or like a dy, you find a derivative and then boop, dx.
Okay.
There's one of those.
And then
Just that's layer derivatives. Well, there's only like 6 problems, 7 problems, and a bonus. It's a quest, not a test, not 100.
I almost finished 7.
And then L'Hopital.
I did this one.
Or DVDR. But probably D1. Oblique asymptote is if the top wins by 1, we do a division. And y equals mx plus z is the dot that comes out of division. So if you had something like
Don't forget to do your notes and stuff, guys.
yeah, like hundreds. Just update table of contents.
I did it.
Great. Everything but the review. Reviews are
I
okay.
have to
This one has an OA already.
Gavin used to do this.
And you would find it by dividing.
When's the review due?
Tomorrow. But it's bonus, so it's optional.
I did eat all of them.
Doesn't go anymore. So the rest is remainder of blah blah blah. Justin.
Wait, PK, are you like okay.
Then that one has HA, not both.
Horizontal class.
We'll never have both. Yeah, Joe. I feel bad.